Okay, so it's agreed. Should we look at 1.2 first of all? Okay, and then I'll take your questions. Okay, 1.2, I am pretty sure you're kind of familiar with it. Okay, so I wouldn't have to set the context. Okay, that's a proof. Okay. Is it even visible for you guys? Is it okay? Okay, I'll try to, I'll enlarge that a little bit. Okay. Basically, I will, rather than going into complete detail for the proof, which will be pretty dry, I'll just highlight to you the parts you want to go over, and also the big picture. That's what I will show. Okay, the proof is not that bad. I think the important thing is don't lose the big picture. Okay, what we want to prove is 1.2. Okay, so now before I try that, let me just tell you something here. Okay, so now you can see that over here it's completely copy and paste from your solution. Okay, so it's easier for you to make notes. So here step number 1, we want to calculate the WP, okay? And for this one, we want to see if the loop body will maintain the loop invariance, okay? So now this part here is the body of the loop, okay? Which means we compare to see whether AI currently is strictly larger than result. In that case, we're going to assign the result to be that. Implicitly, result is assigned to result otherwise, right? That's what we talked about yesterday. Good. And this is the loop invariance that we want to establish. Okay, so now the yellow is the loop body, the body of the loop, and the green part is the loop invariance. So now the first step is to calculate the WP. That part there does not involve any proof. It's only about mechanical application of the WP rules. Okay, let's look at that. I'll just tell you what you should really pay attention to. What we say is, first of all, you want to do the rule for sequential composition. Okay. So you will see that the first part for the sequential composition is over here, and this is the second part in purple. Okay, that's the second part. So what you will make sure is this is the first part, and this is the second part. Okay, and the loop invariant remain the same. Okay, hopefully you can see the picture over here, right? And then after that, so now we basically got two WP somehow nested. And then each one of them contains the if then else, the other one assignments. So now what we will do is we're going to handle this particular WP. I want to handle this particular WP first. That's the first one to really simplify. So what I will do is basically every free occurrence of I is going to be replaced by I plus 1. Okay? So what I will do is I'm going to say now here I minus 1 instead is going to be I plus 1 minus 1. Agree? Because I is replaced by I plus 1. That's the only thing. So that is why in the next one, you will see the loop invariant has become something like this. So the only thing that was changed was this I over here. Okay, that's the only one. Okay, good. So far you're following. And then we're now doing conditional. When you do the conditional, is basically this guy here. Basically say either this condition is true or this condition is not true. So negation of larger than should be less than or equal to. Okay? And then you want to say this. If it is true, I'm going to say result is assigned to AI. Otherwise, result is assigned to result. That's kind of implicit one you should know about. And is Jason here? No, he's not here. Okay, anyway, he was wondering about should you include, hi Jordan, should you include that that particular part, result is assigned to result? Yes, you should. Okay, you shouldn't just say that particular conjunction is true. Okay. Okay, that's about result is assigned to result, and then we are simply going to copy over this guy here, right? Just the same. Okay, so you can see I here and I here from before, right? The I here. Okay, so now we're pretty much done for the WP. Okay, so now what's left is to replace over here. Result is going to be, let's say the first one. Result is going to be substituted by AI. So result over here is going to be substituted by AI. And over here, result is assigned to result. So result remain the same. So that is why eventually what you will get is this. This guy here, number 1, and this guy here, number 2. Okay, you can see that here, AI here, result here. And this is what you will get for the WP calculation. Okay, for the first part, any questions? You can see the first part is actually not much harder than the swap program we did before, right? Basically, you got a sequential composition of several things, and then one of them happens to be if conditional. In that case, well, it will turn out to be just a conjunction to say if the branch is true or the branch is not true, right? Okay. Guys, any question about the first part? If you have, you better say it now. Okay, conjunction, of course. Everybody's comfortable? Are you girls okay over here? Huh? Oh, you cannot see it? Oh, okay, hopefully the recording is successful this time. Okay, you cannot see it. Okay, that's another story. Yeah, so can you guys actually see it at least? Oh, I do apologize if you cannot see it. That's my bad. Okay, but anyway, you know, watch the recording later. Okay. Well, I can go over it with you after the exam. How about that? Would you be interested? Not anymore? Yeah. Okay, anyway, it's a terrible joke. Okay, so now, what about the second part? Okay, let me point out to you very quickly, okay? The second part, basically like this. Basically, the weakest precondition you calculated from the first step is a form like a conjunction, like a P and Q. Right? Think about that, right? It's like a weakest precondition. And now, don't lose the big picture. So what do we want to prove eventually? We want to prove the whole triple, the precondition, implies this particular WP, right? So that's why you can think about what would be the precondition in the whole triple. It's basically not the exit condition, and also the loop invariance over here. Okay? So this is not the exit condition, and this is the loop invariance. Okay? So now we want to make sure not B and loop invariance implies, so now we got P and then we got Q, right? You can think about this guy here is P and this guy over here is Q, right? The whole thing. This is P, this is Q. And P and also Q. Okay, so now in order to prove this, you don't necessarily have to prove this guy over here in one single take. You don't have to. You can say I prove this one implies P and this one implies Q. I can prove them separately, okay? So that's basically the insight you will get. Equivalent to, okay? Not P and loop invariance implies P, number one. And also not B and loop invariance implies Q, okay? So these are the two. And in the solution, I gave to you one of them. This is the one we got to look at. Okay, this is the one. And this one will be something very similar, left as an exercise. Okay, but of course in the exam, if you're given something like this, you got to complete both. Okay. But maybe it's easier if you do them separately. Okay, that's better. Okay, the rest will just be about proving this particular implication. Okay, this one here. Okay, how do we prove it? Okay, let's just go over a little bit into it. I want to show you just the rule you're supposed to use. So you may want to review the part about what will be the whole triple when you want to maintain loop invariance. You to say not terminated yet, and also loop invariance has been maintained from the previous iteration, so that's a precondition. You want to review that part in the lecture. Yeah. Okay. Okay. The only thing I think is worth mentioning is this. Okay. Let's say you want to prove this guy over here. Okay. For every j, and the range of j is between a dot lower and also I. Okay. If you think about it, it's like this. Okay. Let's say we got a dot lower, which is 1. You can assume it is 1. And also, this might be a dot count. That's the end of the array. And then we're talking about this is the current value for the loop counter, I. Okay? And then over here, we're basically saying between a dot lower and also I. A dot lower and I. So that's kind of the range we're talking about. Okay? And for that range over there, for every element in the green area, we want to make sure the following. Okay? J should be valid index over here, right? Should be between a dot lower and also a dot upper. And also AI should be larger than or equal to AJ, right? That's what we want to prove. So now the important property for you to apply, okay? I'm going to write some example for you, okay? Okay, let's say this. If I got something like this, for every x such that 1 less than or equal to x less than or equal to 5. It is the case. Okay? And then I can say maybe x squared is larger than or equal to, for example, 3. Let's say, for example, right? First of all, would that be true or false? False. Very good. Okay. It would be equivalent to saying the following. Basically think about if you kind of unfold it, it will simply be basically 1 square larger than or equal to 3. That's the first possible value. 2 to the power of 2 also larger than or equal to 3. 3 to the 2 larger than or equal to 3. And also 4 to the square larger than or equal to 3. And also 5 squared larger than or equal to 3. Right? And now, how do we combine them together? Conjunction, disjunction, implication. Conjunction, right? Yeah. Okay, so now, because overall it's going to be just a series of conjunctions. So now, the rule comes from, you can group them in whatever way you like. And one way to group them would be, why don't I just group everything except for the last one together, and then leave out the last one, single out. Okay? So now, basically, it's basically saying this. Equivalent to, for every x such that 1 less than or equal to x less than or equal to 4, right? You can see 5 versus 4, okay? It is the case x squared larger than or equal to 3. And, right, it's like an and over here. And then I can say, what's the value that's left out? 5, right? And 5 squared larger than or equal to 3. Right? If you think about it over here, what would be the result for this particular one? It's false, that's fine. And also this one over here is also false. Overall, it's still false. So we're getting consistent result. So that's why they're equivalent. Oh. 5 squared, oh yeah. It's true, right? Yeah, sure. Yeah, sure. You gotta bear with me. I got just 20, 30. Right? Good, true. And then this will be false. You get false. All right, sure. Okay, any question about this particular rule over here? Okay, in general, it will be like this. In general, it's something like this. For every x such that some lower, let me just put I and j, okay? I less than or equal to x less than or equal to j. It is the case some predicate p. Okay, it can be any property, p of x. Okay, so now we can split it up into equivalent to for every x such that I less than or equal to x less than or equal to j minus 1, right? And then px. So now, and what? pj, yes, that's the value we left out, right? Okay, everybody comfortable with this? Okay, good. So now, question for you. Every time you talk about rule for universal quantification, you should talk about something symmetric or similar in existential quantification, okay? Here's my question for you. What if I have, there exists x such that I, okay, the same range, and also p of x, okay? Can I get some splitting the range property for existential? Can I? Okay, I'm asking. Exist x such that I less than or equal to x less than or equal to j minus 1. Okay, the same in case j minus 1, p of x. and pj. So now what should I put to put them together? Or. Very good. Exactly. Okay, you can just make up some example for yourself. Okay. So these two rules will not be given to you. Okay, so you better understand them. Okay. Of course, you don't have to memorize them. You just want to understand conceptually what do you really mean by splitting the range, right? Okay. Okay. After this, okay, this final detail I want to point out in exercise 1.2. We're basically done. Okay. As long as you understand this particular property well, then we are almost done for that exercise over here. The only thing I want to point out is this. Okay. Hopefully it's a little bit better for you. A little bit. Okay. So now thinking this way. So here we say eta lower, and also, oh, let me use different color. Between eta lower and also eta upper. What we do is split that into, oh, sorry about that. I had the wrong thing. Let me do it again. Eta lower and also I. What we will do is we'll split that into eta lower and also I minus 1. Eta lower and also I minus 1 over here. And also we just get I. Okay, that's why you see the split of the range. Okay. Once you get to this part over here, the only two steps left is really about simple arithmetic. For that part, I can leave to you. Okay? Unless you got questions. Yeah, remember the overall theme of this course is about software design, right? So when you talk about design, there are two aspects to the design. Architecture, which means your design pattern, you put different classes together. Also, you talk about bound diagram, etc. Right? The other important aspect would be correctness. How do you judge correctness of your design? One way to do it, you can do by testing, right? We talk about unit testing, we talk about regression testing. Another way to do it is for a very small core part of your code. You may want to do some formal verification without doing any testing. What's the advantage of doing this particular formal proof? That means you don't have to do any testing. It simply works for every possible input value. Yeah, all right. Anyway, it's only an elementary introduction to program correctness. Okay, that's about it. If you are okay, then I can take other questions. Okay, yes. Sure, let me go there first. Program correctness. Yeah, microphone battery is fine. Okay, yeah, I just want to make sure. Otherwise, you're gonna watch the video without my sound. Right? Program correctness. Okay. Sorry. Yes. 17? Okay, sure. One moment. Oh, this one here, yes. I don't have a solution. Huh? I don't have a solution for that actually, but that one should be quite easy, right? So I don't have a solution for that though. So do you guys want me to do it or? Okay, sure, no problem. No problem. Okay, before I jump into it, I would say it would be very nice if you know how to do this basic one, but I would say try to get your study mates together tonight or tomorrow morning. It's 2 p.m., right? You got time, okay? Yeah. Well, I'm sure you got other things to worry about, but if you don't have any other things to do, yeah. Try to get really comfortable with the pattern for 1.2. Okay? Yes. Or the pattern, like a proof, right? For example, you may want to start from calculating WP, and the programming statement has sequential composition, got if statement. That's complicated enough, know how to do that. And also, when you prove the implication, you can prove them separately. And also, when you prove it, you may want to split the range into several parts. That's what I meant. Okay. Sorry? Check, yeah, the video has no sound. Okay, I gotta mention it again. Okay. Okay, so what you will be given tomorrow, if there's any question on program correctness, right? What you will be given Oops, sorry. What you will be given is this. What you will be given is a WP for assignments, okay, and also the WP for if then else, and also the WP for sequential composition. Okay. Those you will be given, no problem. Okay. What you will not be given is the 5 proof obligations for the loops. However, if there's any question about, can you say the following condition is a Hoare triple? For example, given that we are now ready to exit, and also executing the current loop iteration is going to maintain the loop invariance. Can you formulate this as a Hoare triple, for example, right? I hope you can do it. Okay, not given. Okay, let's do this one here. Okay, no problem. Let's start from the very beginning, okay, in case you're still not comfortable with it. Okay. Yeah, before I start, just tell me something. So far, what's really the point about program correctness you're really stuck at? Is it about the WP calculation? What's the overall picture? WP? Well, everything may not be a very useful answer. Yeah, I just want to know so I could. Okay, anyway, I'll just go over that with you. Okay. All right, the question is whether is this program correct? Okay. So now we're gonna basically do several steps, right? Step number 1, you want to formulate a Hoare triple, right? Step number 0, okay, the Hoare triple is going to be x larger than 0 and y larger than 0. Okay, and now only for the illustration, can I just call this B and call this S and call this B and call this S? And don't do that for the exam, okay? Please, okay? All right, let's see. Okay, so now over here I would say if x larger than y, and then you got B is assigned to x, S is assigned to y, okay? Otherwise you get basically B is assigned to y, followed by S is assigned to x, okay? And then the post condition for that would be B is larger than or equal to S. Okay, that's a Hoare triple. Okay, you may be asked to actually formulate that first. Okay, that's 0. Okay, step number 1, we want to calculate the WP. Okay. Okay, let me just make it a little bit smaller. Okay, step number 1. So what I will do is I'm going to calculate the WP. Okay. So now the WP over here for if x larger than y, and then B is assigned to x, S is assigned to y, else B is assigned to y, S is assigned to x. Okay, and the one we want to establish will be B larger than or equal to S. Okay, are we good? All right. Any concerns so far for this one? Yeah? But of course, you know, I would say for now, it's most important if you got any understanding that's not really getting through, you should really let me know, right? Everything is recorded, so you can definitely take the notes later. But if there's anything that's bothering you, you should let me know now. Okay. Okay, so now the question is, what rule should we apply? Overall, if you look at the code over here, overall, is it just, should we apply the assignment first? Or should we apply the sequential composition first, or should we apply the if then else first? If then else? Okay. You can see just overall the program just if then else, right? And then and then nested within each branch, you got sequential composition, right? Okay. That's something you got to judge. Okay. What I would do is over here I would say WP rule for if then else. Okay, so now what would that be? Okay, it's going to be something like this. X larger than y, x less than or equal to y, right? Either way. X larger than y implies that this branch is able to establish the postcondition, right? So now this will be basically B is assigned to x, x is assigned to y. B is assigned to x, followed by S is assigned to y. And that one there is going to establish this. B larger than or equal to S. Okay, and also here WP. Okay, so now we got the second part, which will be over here. B is assigned to y, and also S is assigned to x. And then B is larger than or equal to S. You can see over here, the postcondition will be the same thing that we want to establish at the end. Okay, yes? Yeah, negation of x larger than y. Yeah, that's x, oh yeah, yeah. You know what, actually in some way I agree with you. I personally actually wouldn't mind if I just put this. That might be a little bit clearer. How about that? Okay, yeah, that's good. Okay. So now, what I will do is I'm going to do a little bit of simplification, okay? Over here, we can allow certain little bit of flexibility over here, okay? So to be fair. So now, what I would say is, let's say for this guy here, how do I simplify this a little bit further? Okay? So over here, I would say the blue one, WP of B is assigned to X, followed by S is assigned to Y to establish B is larger than or equal to S. Okay? So now you can see we are only got two sequential compositions, right? It's just two things to actually handle. Okay? So what I would do is I'm going to say the rule for sequential composition. Okay? So now, Chelsea, tell me what I should write. Just tell me exactly what to write. Very good. Thank you. Okay, please make sure you're comfortable with this. Okay? So now there's no more sequential composition to get rid of, right? No more. So now what I will do is I'm going to say, okay, first of all, I'm going to get rid of this particular assignment over here. Okay? So now I would say rule for assignments. Oh, sorry, that's not assignments. Rule for assignments over here. So now S is now going to be replaced by Y, right? You can make a little bit sketch over here for yourself. So what you will get is WP, B is assigned to X, verbatim, okay? And then, so now B is larger than or equal to Y, okay? Let's do one more. And then the rule for assignments over here, okay? So now B over here will be replaced by X. So now what do we get? X larger than or equal to Y. Okay, so now that means this blue part here, let's go back here. So that means we calculate X larger than or equal to Y. So now you got basically this guy here. X larger than Y implies X larger than or equal to Y. Okay, that's one thing here. Is that true? Yeah, if the left side is true, the right hand side is always true. Okay, in case you have a little bit doubts, let's talk about converse, just for your information. If I say X larger than or equal to Y implies X larger than Y, can I say that? No, right? Because in this case, if x is strictly equal to y, in that case, this will not be the case, right? So this is not good, okay, just for your information. Okay, so now we can simplify this particular conjunct to be true. Yes? Oh, okay, we'll put it this way. No worries, okay. In case you got a little bit trouble here, can I just rewrite this to be x greater than y implies x larger than y or x equal to y. Now it makes sense, right? Yeah. No worries. Yeah, you know what? It's actually good because you don't memorize this kind of property, right? If you really get confused in the exam, rewrite this way. Yeah, that will help you. Yeah, no problem. Okay, so now we can easily prove that the left conjunct for the WP is actually true, the left one. So now the question is, will the right conjunct to be true as well? Should I do that as well, or you're fine to do that as an exercise? Exercise, okay? Okay, good. Oh, can I do it? Okay, I will do it. Okay. No worries, I'll do it. All right. Okay, so now let's say this. How do we simplify this guy over here, okay? Yeah, it's going to be very similar. Okay, you know what? Sketch a little bit for you. That can save a little bit of time so you can ask more questions about other things. Yeah, you can think about this. How do you simplify this guy here? Think about, basically, it's the same sequential, it's basically just about assignments over here, okay? Basically, when you try to simplify this guy here, replace s by x. And also replace b by y. So b by y. You still got b larger than or equal to x. Right? Y larger than or equal to x. And then you can easily prove that implication. Okay? Are you fine or? You're fine, right? I can repeat that, of course. Of course I can. Let me sketch. Of course, eventually you're going to first do this substitution. S will be replaced by x. Okay? And then when you do the second substitution, you're going to get b is replaced by y. So b is replaced by y. So what you get is y larger than or equal to x. Agree? Okay. So now this guy here, if you just simplify the negation, so it will be x less than or equal to y. So now x less than or equal to y implies y larger than or equal to x. Can you see they are the same? They're the same, right? Just reverse the position. Okay, this one is even easier than the previous one. Okay, check. Okay, so you basically got true and true. And now, what will be the second step? Chelsea, second step. Okay, exactly. So precondition is here, agree? Okay, so that's x larger than, x larger than 0, and y larger than 0 implies true, which is true. Everything implies true. So that means this program here is correct. Okay. Maybe when you study tonight about program correctness, try to do one of the basic ones that we went over. Maybe this one here, together with the max that we talked about yesterday, right? That one's also similar, without a loop. And then make sure you can also do things similar to 1.2. Okay, then you're ready. Okay. Any more questions about this particular example? Yes. Say it again, I don't quite catch you. The rule for assignment, yeah, that will be given to you. Okay. One more thing to mention, okay? Regarding what will be given to you, okay? One thing over here. If you got Q here, S over here, and then R here. That's a whole triple, right? It is true if and only if Q implies the WP for S to establish R. This will not be given to you. That's something you should know. Okay, just to mention that. And what does it really mean for this particular Hoare triple? If there's a definition question. Anybody want to try? What does it really mean when I write this Hoare triple here? What does it really mean? Anybody from this side want to try? Ah, Uma, yes. Oh, no, not really. I'm just trying to, okay. You are not trying to explain this one here to me. No, not really. I want to explain to you what does it really mean for this Hoare triple. What do I mean by saying this particular Hoare triple is correct? What do I mean by that? So somehow you want to, you answer like a definition for the Hoare triple. You want to somehow mention about the precondition Q, the postcondition R, and also S. Yes, go ahead. Yeah. Yeah. Exactly true. Okay. Basically, you start in a state that satisfies Q as a precondition, right? And then you execute the program S, and it terminates. Okay. And then you establish the postcondition R. Okay. That's something you also should know. Yeah. Sorry? You mean in the exam? Okay, the question was, can you use any function like a domain range? I would say yes if you find it useful. Yes. Mm-hmm. All right. Any more question about program correctness? Yes.
Yesterday was not recording, so I have to be asking the same question. But
yeah, you can ask me the same. Yes, yeah, that's fine.
So what you're going to give an exam is like something like the, for example, like at the end of S body is not to exit, then I loop invariant is maintained. Something like the sentence, like such as this, right?
You mean, okay, are you asking about how do I phrase it, or?
How you given like the question to build it, like how you given like.
You mean the maintenance of loop invariant, right?
Yes.
Okay. The question could be something like this. Okay, could be. Let's say, okay, well, first, depends on how I phrase it, right? How I phrase it now may be different from how I phrase it on the exam, right? Different, okay? Or similar, you wouldn't be too surprising, okay? Given that the loop is not ready to exit, and that the loop invariance has been maintained by previous iterations. Go given two things, okay? The current iteration maintains the loop invariance. Okay, that's basically maybe not exactly how I phrased it yesterday, but I think pretty much the same idea. Okay, how do you formulate it? Right, I'll just write it down. Okay, if you remember, basically you got from S init invariance. Let's say Li. And also until some B, okay, that's what we've been using. And also loop. And then over here you got the body of the loop. And also you got variance, okay, V, right? That's the complete syntax. You don't need to memorize the syntax, okay? It will be given to you, okay? Yes, good. So now what should we do? Okay, basically see this. When you say that the loop is not yet ready to exit, so that means this is false, right? So that means not B. And also that loop invariant has been maintained by previous iteration, which means it is true. Okay, so now what you will do is you'll simply say, okay, loop invariance over here, so you say and Li, okay? That's basically the starting condition for the loop body, the body of the loop. The current iteration, which means you're going to execute the body of the loop for one more time. So you say the body of the loop, and then it's going to establish the loop invariant, which means this will be maintained, so Li. You might be given this and then explain this. Or you might be given this and formulate into this. Okay? Not both. Okay, not both. Either one. Okay. Yeah, for the exam tomorrow, I believe you will see some question that will definitely require some thinking. You may just skip them in the first place. Try to answer all those straightforward questions that we have been talking about in the course, in the class. At least 50% of them, at least, or more than that, are straightforwards. You can definitely answer them first and try to do them maybe within 90 minutes. And then for the remaining time, you can think about a little bit more about the harder questions. Okay. Yes. Oh, will you be asked to come up with a loop invariant and variant? Yes, you will be. Okay, I tell you, you will be. However, I would say for the loop invariants, the best hints I can give will be think about what's the corresponding postcondition. Okay, for example, let's say finding the maximum. The maximum will be the result should be the maximum for the entire array. The loop invariant just be of the subarray of what you have found so far. Okay. Variant, yeah, that is, yeah, true. Variant basically just measures about how many iterations you want to have, right? So variant as well. You want to know what's really what's not acceptable for the variant, right? You want to make sure it's strictly decreasing and also non-negative, right? Things like that. Mm-hmm. Mm-hmm. Okay.
I want to understand more. So like when you see the model, view controller kind of pattern in the project, you kind of tell us more about that. I haven't really covered
Yeah, model view controller is not really covered in this course. I can just mention briefly, okay? But since we said ETF is not covered, so I'm not too sure if the guys are so interested. But I can talk about briefly. How about I spend a few minutes talking about it? Would that be okay? No? You're not interested? Okay, sure? It's your time, so I wouldn't force you anything I want to talk about. So that's fine. Go ahead.
For slide of correctness, in the slide number 35, there's a question to formulate invariant.
Which slide?
Slide number 35.
Okay. Sure. Basically, okay, you know what? This one, again, exercise is exercise, right? I'll still want you to think about it, but I'll give you more precise hints, okay? Because if you don't think about it, you're going to suffer in some other question in the exam, okay? It was similar. Okay, how about this? I'll tell you informally, okay? Okay, think about what the first one is trying to say. The first one is saying for every k in the result, the corresponding element for the k is equal to v. How about just talk about this particular one, okay? Just copy that here. Apparently, this one is using math models, okay? So you may or may not have the math model available to you, but it will be explicit in the exam. So. Okay, over here, okay? So this is the postcondition you have over here. Okay, so now basically, if you go back to the loop, you basically got some loop counter, right? Again, you should really have I is assigned to I plus 1 for sure, okay? It's just a typo. Let's say you got I is a loop counter, right? So now basically we got keys. Oh, KS. Okay, let me just be consistent with the variable name. You got keys and got values. Okay. Assuming that the length are the same. Okay. Okay, for example, let's say this. If I got K1, V1, and also K2, V2, and also K3, and also V1, okay? You can have duplicates in the value, right? That's something also you're supposed to know from the exercise for the lab test, okay? Let's say, for example, let's say the value of I is currently just around here. So that means so far we have covered this part of the array. The remaining part is yet to be covered. So that means the loop invariant should really cover this part and also this part only. Okay? All right. Are you okay with that? Okay. So now what you have to say informally is like this. For, okay, I can do a little bit more formal for you. That's not a problem. You can say for every I, maybe put j, so you don't get confused with I. Let's say for every j, such that, okay, 1 less than or equal to j, less than or equal to I, for example, right? Or minus 1, I minus 1, depending on the setup, okay? I'm just sketching the idea for you, okay? It is the case, I want to say the following. The result, let's say the result, iterable, right? Let's talk about it as like a set. If, let's say the one I want, let's say, what's the feature name? It's called get keys, okay. If I'm calling this, just for example, let's say get keys. And then I simply say V1, okay? So now, eventually, I might get some very big set, in the result, depending on how many values V1 will be mapped to the keys. Let's say up to now, I'm now after I iteration, I is now pointing to there. I have scanned 3 entries so far. What should be the result so far? K1, K1 and K3. Agree? Okay. So far, K1 and also K3, right? You basically got K1 here, you got K3 over here. Agree? Okay. Basically, the first postcondition here, which I can make a special case of to make a loop invariant, is to say, out of this particular range of the keys over here, if somehow the corresponding key has its corresponding value being V1, so that means that particular key must be in the result, right? You see what I mean? Okay, now, why don't you help me a little bit? If I just give you the answer, you're not learning, right? Anybody want to try? So collectively, you can come up with the answer. What should I do? Anybody? Jordan, any thoughts? Please. I know you're shy, but no worries. No worries. Chelsea, any idea? Nope. How about your friend? Sorry, I just forgot your name. Just go ahead. Okay, how about okay, that's very good. Oh, first of all, it's a very important point. Okay, I'm glad you mentioned that. Result over here is of type iterable, which means you cannot say result has. Agree? Okay, I agree with you. Let's make it slightly simpler for you, slightly, okay? Let's assume result is an array. Let's say we can do that, okay? So what should I write? Tell me what I should write. How do I find the corresponding value for? Okay, so this is like an index, right? Like an index J. How do I find the key I'm looking at? Well, if the J is what I'm looking at, so now given some particular index J, how do I know what's the corresponding key and the corresponding value? Huh? Keys at J and also values at J, right? So now I know that I can now write something like keys at particular index J and also values at index J, right? So now what I want to say is this. If somehow values J is equal to the V1, for example, I'm looking at, so now keys J must be in the result. If it's equal to or not? Tell that? Implies, okay, just say imply. Okay, of course you want to be, yeah, implies. Okay, I'll say result that has for now. Okay, implies result that has. Okay, and then, okay, it's kind of similar to what you would have to write for the labs, right? Just that we don't really use math model here. Conceptually, that's right, but it's not quite right because, as you said, result statically is iterable, right? So this guy here, result that has over here, this is iterable. Okay, so this does not compile. So what you have to do, what should you have to do? You got two options here. Either you can simply maybe define an auxiliary query to actually go over the result to see if that's there. That's one option there, which you did maybe in your lab test. But this option here is dangerous because I may say you are not allowed to use auxiliary query. So you may want to get prepared for second option. What will be the second option? Let's say I don't allow you to use any auxiliary query. Across, I agree with you. Across all, across sum, across loop. Across sum, good. Okay. So that means somehow you may want to replace this guy over here by across something. Okay, but you know the get idea. Okay. And now the second one, okay, you will do something very similar. But now, let me just help you read this a little bit, okay? The first one is saying everything in the result, K1 and K3, they have their corresponding value being V1. So that means everything that's in the result is actually correct. But we are not too sure if everything that should be included is actually included, okay? Let me just draw one more picture for you, okay? One more. Okay. Okay, what I would do is think about if this is like your repository. And conceptually, this is the result. If I talk about get keys, okay, I just give a particular value, let's say V, okay? There is a subset of the repository over here where I might have K1 mapping to V, and also K2 mapping to V, and also K3 mapping to V. Only these. Other things, for example, K4 is mapping to maybe V2, right? Just not mapping to V, okay? We are saying that this particular subset where the keys, right? This particular set of keys is equal to this particular set of keys. That's what we are trying to say, right? Conceptually, okay? Get the idea first. And now over here we got K1, we got K2, we got K3, right? Let's say this is S, this is T. I want to prove that S is equal to T. Well, back in 1090, how do you prove that? S subset of T, and also T subset of S. That's basically what we're doing, okay? And this particular guy here, when we say result is valid, every key in the result is in that particular, has the corresponding elements, right? So this is basically doing this, okay? That's something you want to convince yourself, okay? So now the question is, how do we do this one here, okay? That one, you got to finish that. That one there is saying that somehow you go over the repository for every entries over here whose corresponding value is actually V. Their corresponding key must be in the result. Okay? Yes. Can you say it again? Can you? Yes, you're basically saying if we have the math model ready, yes, if the math model like a relation is given to you, feel free, no problem. But it might be that we want you to only write contracts in terms of keys and values. So you want to do both. Yeah. In the exam, if there's any restriction we have, you better follow them. That will be explicit. Any restriction we didn't say, you don't have to worry. You can just do whatever you like. Okay. Yeah. Mm-hmm. Yeah, if you use for all exist, things like that. Yeah. No, actually, in the question, I'll be very precise. If I say now, write the contracts maybe in predicate logic. In that case, you got to write for all exist. If I say write using valid IFO syntax, then you got to use across, for example.
In that case, we use the combination form.
No, in that case, well, over there, I simply just use yeah, over here, basically, as I said, this guy here is not valid because the result is actually iterable. It's not even. It does not support has. So you have to expand that further, right? Okay. Yeah, knowing how to write nested across might be useful. Yes, Ada. Is it the best solution? Oh, that's actually definitely good because remember over here, we have, okay, basically just make story short. Basically, every time if you want to go over a particular range over here, you want to say only for those elements that will actually satisfy this. That means this particular element, this constraint is satisfied. That's why implication is good. Okay. What if you don't have that? Okay. Values of j is equal to v1. Oh, okay, I can give you, okay. That could be a good question. Okay. Guys, think about this. Okay, I'll make this question for you. Hypothetically, okay, the correct result should be implies. If I change this to be n, okay, why would that be inappropriate? And I'll help you a little bit. If I simply change implies to n, it will be inappropriate because somehow you're going to have a violation when there shouldn't be a violation. Aha, very good, very good. That's exactly right. Okay, okay, I'll just repeat what you just said. Okay, very good. Okay, so now over here, let's think about this. Let's say we're using the n over here. The first iteration we are fine because v1 over here is equal to v1. That's true. And also, k1 is also in the result, so we are fine. So for the first iteration, right? For the second iteration, we got v2, which is okay because the repository might contain something that's not v1, right? So now if this is v2, so now values j will be v2. v2 tilde v1 will be false. False and anything will just be false. So you get a violation right away. But that's not right because there's nothing wrong. It's just that the value you're looking at is not the one you're searching for, right? So that's why, okay, so two things we're learning for this example, right? So one is about how to write a looping variance. Number two, if I change implies to end, why would that be wrong? So two things, okay? Both are important, okay? Yes. How would you loop the subdomain? Okay. Yeah, yeah. You're right. If you want to force a subdomain, let me think very quickly. So again, you know, if anything we give to you, that should be doable, right, in the exam. So let me just think about it very quickly, okay? So over here, apparently in the postcondition here, we can simply say model.item over here. We just say k is a result, okay? Yeah, how do you say subdomain? I would say, as far as subdomain is concerned, I don't think that's doable in this context. So if we really ask you something similar, we'll make sure it's explicit about what you can use. Yeah. Okay. Yes. Proof by, you mean, what do you mean? Which one? Yeah, so how do you judge to see this one is not appropriate? Yeah, that's exactly what I just said, right? You just say, if you actually is reiterating through some value that's not exactly v1 in this case, so that will give you violation, right? That's a counterexample. English is fine, yeah. I'm not saying English is fine in general. I'm just saying depending on the question, right? If I simply say, I want you to justify, of course, you got to write in English. Right? Okay, anything else? Well, you still got 15 minutes if you want to use it up. Right? You don't have to, but if you want to, that's fine. Yeah. Speak up a little bit, please. Yeah. Uh-huh. 39? 39, okay, let me go there first. Program correctness, and go to 39. Okay, go ahead, yes. Oh, okay, good. Well, this, basically, okay, one possible exam question could be, I will give you informal description like this, and then you have to formulate like this. But it's not like you're going to memorize the code. Of course, the code will be given to you as well, just a copy and paste, right? So what you should know, I think you pointed out yesterday, right? Not you, another guy. Okay. What you should know is get familiar with this description here. So what I would say is that would be very similar to these. Not exact wording, but very similar. Mm-hmm.
When I got to the, like once I did all the WP steps and I got to the final answer, I struggled to understand what it meant.
What it meant? You mean for which one? For one. No worries. Are you talking about this guy here? This one here? Oh, 39. Oh, I mean this guy here. Oh, you just don't know what it really meant. Okay, no worries. That's fine. Why don't we do it quickly? This one is not complicated. But you're definitely okay with the WP calculation, right? Okay, sure. Yeah, it's important to understand what it means. It's important. Oh, did I copy that? Okay, let me do it again. Okay, let me copy this fragment here. Okay. Okay, good. Okay, let me just calculate very quickly. That one's easy. Okay, this one here. So this is basically the first proof obligation to say, given that the loop start with some precondition true, and then we do the initialization, and then we want to establish the loop invariant. Okay, good. So now this is what is, okay, let's do, first of all, WP for I is assigned to A dot lower, followed by result is assigned to AI. Okay, establish the loop invariant here for every j such that A dot lower, and you can feel free to replace it by 1. That's fine. Less than with the j, less than I. It is the case. Result larger than or equal to AJ. Okay, good. And then, so now, well, I can use the sequential composition rule, right? Okay, so rule for sequential composition. Okay, so WP over here, A is assigned to A dot lower, and then to establish WP for result is assigned to AI to establish for every j A dot lower less than or equal to j less than I, and then result larger than or equal to AJ. Okay, good. So now let's simplify that, right? We can just use assignments. Rule for assignments. Okay, I'm just going to do 2 at a time, okay? You know what? In the exam, I tell you this. It is not so recommended if you try to do 2 substitutions at the same time because it's easy to make a mistake. But if you really want to do 2 at the same time, if you didn't, make sure you know what you're doing. If you really end up with something that's not wrong, it's okay. Okay? But I would say to be safe, right? You want to do 1 at a time. Okay, for now, I'm just going to do, okay, first of all, R is going to be replaced by AI, right? R will be replaced by AI. I'm just sketching for myself, okay? And then I will be replaced by A dot lower. I will be replaced by A dot lower. Okay, so now eventually what I will get is, for every J, A dot lower less than or equal to J, less than A dot lower, it is the case AI larger than or equal to AJ. Yep, let me see. You mean, yes, yes. You mean the second AI? Okay, sorry, which one are you talking about? So here, so this one is replaced by AI, right? You're okay with that? And also I is replaced by A dot lower. So only this one is to be replaced. Which index? You mean over here? Oh, you're right. Yeah. So that's why, yeah, that's what I said. You got to know what you're doing. Apparently, I didn't know what I'm doing, right? But the good thing is I'm not taking the exam, right? That's the wonderful part, right? Yeah. Okay, you're right. I agree with you. It's good. Absolutely. Okay, good. Okay, you know what? It doesn't quite matter this much, right? Because it will turn out. Oh, yeah, question?
So under this situation, when we just involve with the array indexing, do we necessarily to have an augmented constraint?
You know, actually, I think you should. Okay, I think you should. I would say, you know what? At the end of the day, I would say the augmenting the array by, let's say you're using index I. You want to make sure I is between lower and upper. It will turn out, in some cases, it will definitely help you prove. If you want to get to some point where you just get stuck, they can just help. In this case, it's not necessary. Okay. Okay, good. So now let's go a little bit further. So Tammy, I'm pretty sure you're okay up to here, right? Okay, good. So now let's have a look. Before I explain to you the insight, we know that for this particular guy here, we know that it's simply not possible to have J such that it's strictly less than A dot lower, which is 1. And also it's larger than or equal to 1. It's not possible, right? First of all, are you okay with that? Oh, you don't know what I mean. Okay. We're thinking this way. We're splitting this into A dot lower less than or equal to J and J less than A dot lower. A dot lower, we know simply just 1. Is it possible for you to find such a J being integer that is strictly less than 1, at the same time larger than or equal to 1? Not possible, right? Good. Okay. So now that means this part here is simply just false. And we said before, if you got for every x, for example, and then the range part is simply just false, and then we want to say P of x, that will simply be true, because you cannot find any violation case in the range. Okay, let me go a little bit further. Okay, maybe that's really what your original question was. So this guy here is saying that the weakest precondition for the initialization part to establish looping invariant is simply just true. Okay, and then the whole thing, we know that is actually true. First of all, the whole thing over here is just going to be true. And then second step, true implies true will just be true. Okay with that. Okay, now let me explain to you the intuition. Let's say this is the array we want to look at. A over here, let's say index 1, index 2, index 3, all the way to here. Okay? So now we are basically at the beginning of the loop, right? Remember the syntax of the loop. Okay, let me just show you here. Remember invariant was actually checked even before the very first iteration, right? That's the very first time. Okay? How do we handle that case? In that case, that means we have not scanned any elements in the array. It's like an empty set of element we have scanned. So that's why this range being empty seems to say initially we have not done anything. Of course, the looping invariant will be satisfied, trivially. On the other hand, as we said before, if you somehow changed the looping invariance a little bit, if you change this guy here to be less than I into less than or equal to I, that you get some trouble, right, for the looping invariance. Okay? Maybe review that part as well. But that answers your question, I hope. Yeah. Okay, any other questions? Yeah, as I just demonstrated, when you do this question here, please be careful. Okay.
Just wondering, how many like correctness exam like questions gonna be like? It is more like how much percentage like you're gonna put in correctness exam?
There's one question on the correctness. I can tell you. There's one question. That question has 3 parts. Yeah, yeah. So not like a single question. Yeah, 3 or 4 parts. I forgot. Yes. Yes, you only have to prove one of them. Which one, I cannot tell you. Yeah. Yes, basically for proof correctness, you definitely have to review loop invariants. You have to review loop variants also to know how to do proof. You'll be asked all of them tomorrow. Okay. Yeah. You mean observer? Just observer or event driven?
We're going to split into 2 during that lecture.
Yeah, okay. So, okay, I might see what you mean. All right. Okay, if you go to the observer lecture over there, okay. Oh, here. I'm not sure if you have any more printing quota. A nice way to review the design pattern would be, why don't you print out every the architecture diagram for every design pattern, and then just to review yourself, to look at the pattern there and tell yourself some story about how the pattern is supposed to work. If you still got print quota, okay. One thing you can do. Okay, so now for this particular lecture here, okay. For observer pattern, of course, you should know, if I give you something like this, you should know what it means, right? Okay. And of course, this diagram is also very important about observer. Make sure you know how to draw them, okay? Now, of course, not only just this pattern, others as well. And then for observer, I would say you should know the architecture. I also know about implementation, both. How to establish bidirectional links between a subject and observer, right? For event-driven part, okay, know about the concept about limitation over here, why it will add up complexity, okay? And for the purpose of the exam, you can skip the Java part. That's okay. You don't need to know them, okay? Okay, and then for the event-driven part, if you got any question on this, you will be given an event class. Okay, event class will be given to you if there's any question on that. And then all you have to know is about how you can, basically about how to do the publish. Okay, here, which is very easy, publish. And also more importantly, how you can subscribe. Okay, what about the word agent? I would say that's the only occasion you have to know how to use agent. That's the only case. Okay. Yes?
Are we going to expect like,
It's okay, go ahead. Yeah, that's fine.
are we going to expect like event-driven design in other patterns or only just observing?
I would say event-driven, yeah, just, well, event-driven design is actually for this kind of problem. So, yeah, it's not going to be mixed up with other patterns. Yeah. Yes? Okay. Oh, okay, good question. The question was, okay, we'll go there. Possibly, I'll get both of them. Okay, maybe a bit too small, right? Okay, that's a bit better. Okay, so the question was, so now you can see this is actually how I subscribed a particular observer, like a weather app, like a weather station app to the events. Okay, so weather data over here, and then you get the events. So this is the events, and then subscribe. Okay, let's see what's the expected type from the subscribe. Okay, that's important. Okay, so if I go to the event class, as I said, I'll give you the event class. You don't need to memorize that. Okay, if you look at the event class over here, okay, now what's the type for the parameter? Some procedure, which means conceptually, I'm taking not just a single integer, I'm not taking like a string, I'm taking like a pointer to function, like a pointer. It's more like what you learned in 2031, like a pointer to function. It's a procedure, just a class in iPhone. Okay, so now your question was, oh, the way for you to get a pointer to function is by saying what a function name is, and then put agent in front. It's a little bit like this. If you say f, it's like a function call. If you put, I believe in star, right? That's how you do the, this address operator. That's how you get the address of something, right? And then when you call that, you got to dereference that. Well, just making some connection there. Okay. Anyway, so now if you get rid of agents, it's not going to compile, simply because what you're doing over here is not really giving a pointer to function. You're just calling the function right away. Well, okay. Think about update over here. What's the type? It's a command. No type, like a void in Java, right? I'll just say void here. But we're exciting a procedure, so the type doesn't match. But conceptually, you're not doing the right thing. The reason we're using agent is because we want to delay the execution for this particular updates to later, right? Good. All right. Questions? Yes, you can ask. Google Doc, sure. Google Doc. Okay, let me go to Google Doc. Okay, 3311, 419. Which one? Sure. Oh, okay. I talk about this, you mean this one here, right? This exercise per se. Okay, sure. Yeah. Give me one moment. I'm going to find it out. Okay. I believe it's one of, it should be in the inheritance lecture. Yeah, bear with me. I'll find it out. Oh, there we go. I find it. Okay, good. So now let me go back there. This one here, right? Okay, good. Okay. First of all, are you okay with testing postcondition in general? Creating a bad descendants and then test it, right? Okay, how about this one here? Good. Okay. First of all, this guy over here is remember in that particular lecture we gave you like 5 versions of the deep twin, right? That's a final version, that's correct, okay? This is saying, okay, you may want to review the complete postcondition lecture. I think that'll be useful for tomorrow as well, okay? Across the deep twin of the old copy, right, of the accounts, we want to make sure if the account we are looking at has the owner that's the same as n. So that means that's the one we want to deposit into, right? We want to make sure, in that case, if that's not equal to, I forgot a negation here. If that's not the same, then we're simply going to make sure they stay the same, basically, okay? So now the question is, how can we somehow violate this postcondition, okay? The way to do that is, I need to somehow add in something that's bad. How do I do that? Okay, I'll give you one example. Okay. Oh, another angry person. Okay. Yeah. Okay, so now let's say this. We got accounts over here. Accounts is simply an array of accounts, right? Okay, over here. Let me say, for example, let's say we got one account over here. Okay, I wouldn't say the owner. That's okay. Account? Okay, 2 accounts, let's say, for example, okay? And then let's say, since we got O keyword over here, is accounts that deep twin. We agree that it's going to make a deep copy, right? So that means old accounts and deep twin. Implicitly, right, there will be some cache variable. It's going to point to a completely fresh copy. And then it's going to make a first copy of the account, copy of that, and also this one over here is also going to be a copy of that. Okay, so far so good. Okay, so now how can I inject some error over here so that I can trigger exactly this violation? So let's first think about how can I trigger this violation? This particular post condition over here, let's say I'm trying to search for Alan, for example. I want to deposit only for Alan. Let's say, for example, Alan is over here. Let's say this is Mark. Alan here and Mark over here. The post condition is saying if the account I'm looking at is not Alan, for example, Mark over here, then this object should stay the same. So cursor, the item over here, is crossing the old copy, which means Mark, the object over here, should be the same as account of is calling on the same at the current one. Okay, sorry, I circled the wrong thing. Let me do it again. Cursor, the item over here, is going across the old copy. So we'll talk about the Mark over here. And then account of, and also Mark, is going to talk about this particular blue objects. I'm saying that since Mark is not intended to be changed, so they should stay the same. Okay, good. That's how you make the post condition pass. But now we want to trigger a violation, right? How do I trigger a violation? Why don't I deposit something into Mark, right? Yeah. So I can tell you that a very easy way to do it would be something like this. Why don't I do this? Okay, I'll just add in some line. Okay. I can simply say something like, oh, that's exactly here, right? Sorry, I forgot to put a solution for you. I thought I didn't put a solution. So what this one is doing is, assuming that the one we want to change is at the second position, but now I'm also modifying the first position, which is A lower, right? In that case, I'm also modifying, maybe I should really say 2 here, according to the diagram, right? So now I'm saying that I'm also going to modify Mark over here. So the green one is actually being modified. So now, is this object over here the same as this one here anymore? Not quite, because I already modified that. Does it make sense? Actually, this pattern here is also important, right? You want to know how to test the post-condition violation. Any part you don't get, let me know. You got it? Okay, you first, and then Chelsea. Yeah.
So I'm just confused about like what did you like? I now kind of understand that like how you since it's not making the inheritance of the bad, I mean the bank as the bad parents of the bank, but like still like I just now understanding what the due proceed precursor.
Oh, the precursor.
Yeah.
The precursor over here is basically, well, precursor is actually nothing new. The precursor is like a super in Java, right? So precursor is saying, I'm calling the deposit on this particular feature here. I'm calling the version of the bank class, which I inherit from, right? I'm basically just calling whatever that's in the body of the loop. This one here.
It is meaning like doing same thing as like the parent.
Yeah, basically doing something that's totally correct and then inject some error at the end.
And
right?
also the new one is like suggest the lines, the accounts, deposit.
Yeah, that the red line over there is just introducing some error. That's something which just made the implementation wrong. If the wrong implementation triggers the post-condition violation, that's a successful test. Okay. Yes? Sure? Okay, just before we go there, are we okay with this? You okay with that? Are you sure? That's the last chance. Well, what is last chance? I mean, before the exam, right? Huh? Okay. Okay, guys, please. Okay, so what are you suggesting? You mean over here? You don't want this line here? The top, yes. What about it? Oh, you mean over here? Yeah. You may say something like balance is equal to O balance. You may say that. Yeah, that's fine. Well, of course, of course, if I got that particular post condition, I may have to modify this slightly differently. Maybe I'll simply change the name. Maybe I'll change from Alan to maybe Jonathan, for example, right? So that's not good either. Well, it depends on exactly how the setup is like. So I can just inject some error that cannot be caught. Okay, question about this? No. Okay. Anything about? If not, and I'll talk about them first, and I'll talk about you. Okay. Any question about this particular pattern here? Okay. Before I move on to another topic. You okay with that? Okay. You.
So something kind of similar, but like, can you quickly define like, so what's the difference with tilde and I mean, why you have to using the, I mean, the old item.
So equals sign is like a reference equality, right? Just like an equals in Java. Tilde, you're just calling object for object equality, like a is equal.
But I think I studied the slides, but like something different in the expanded class, like. It is
So you may want to review that expanded class. In that case, when you say equals and tilde, they are the same.
Okay, got it.
Yeah.
This one.
Okay, good. Any question about this? Good. Okay, your question. Slide 20 for which one lecture? Event-driven lecture. Yeah. 29? Sure. Yes. Oh, you mean over here? Sure, no problem. So basically, remember for once routine, the only occasion, well, the main occasion we use once routine was in the singleton pattern. So that's because, think about how this is going to be executed. So the question was why we want to have the once keyword over here. Okay, let's say, what if you don't use the once, okay? The idea would be, let me just make a copy anyway, so that might be easier. Okay. Okay, so now over here, okay, so now to really understand why we should really use once, let's think about what about we don't use once. Just say do. If we do this one here, so that simply means every time when we call change on temperature, it's simply going to give it a new event objects. Okay? So now let's say this. Let's say we got this weather app. Let's say weather app 1. Weather app 2. Okay? Just weather app. Okay? When I first create the first app, I should really subscribe it to the events, right? So now I'm gonna subscribe to this particular event. So because I'm called do. So what I'll do is I'll call change on temperature is just going to be an event over here. And then over there, I think there's something called maybe a procedural observer, something like that. Okay, it's simply going to be a list, and now it is going to point to this particular app. It's okay for the first time. Okay, so now let's say we try to create the second weather app. And now, if you try to subscribe, you will call change on temperature the second time. Is that going to keep this original copy? Or is it going to create something new? Something new, right? Okay, so that means change on temperature in this case is just going to be a brand new events objects. Where some observer or procedure I forgot, okay? That one somehow just going to be a new one. And that one is also just going to point to here. That's not good. You want to accumulate, want to be shared. Yeah, something like that. It's like a share event. Well, think about as we said, when we talk about the once, it's a little bit similar to static in Java, which means it's not going to be it's going to be shared by all the objects of the same class. I think the reason that we want to make a query is we want to make it a little bit flexible in the sense that maybe later for extension, maybe not only that you want to create a result, maybe you want to do a little bit more things set up for the event so you can make it in a single place. Yeah, that was just for extension for later. But if you want to make it action, that's also fine. Yeah. Yeah. How can I say it again? I don't catch you.
So there's no creation procedure after the result, so I don't know how do we create the object.
Oh, okay. You know what? Similar to Java. Let's say in Java, if you have a class without ever explicitly declaring a constructor, you have some default constructor over there, right? Similar in IFO. Okay. So in IFO, this is one kind of minor point. Okay. If I have a class over here, let's say class foo. Okay, and then I can simply say creates, default creates. Some of you might have used this in the project, I'm not too sure, maybe. And then over here you can say, feature. Let's say I type integer. Okay, let's say I do that. So now if I declare objects of type foo, so now I can say two things. I can either say creates obj dot default creates. Okay, you can spell it out. Okay, or for this one I can make it simpler. I can say creates just obj. Implicitly I'm calling default creates. That's also fine. Yeah, that's a syntactic point. Yeah. All right. Any more questions? Yes.
How do you define the uniform access principle? And do you mind giving us examples?
Sure. Uniform access principle. Yeah, that one is briefly mentioned in the tutorial, right? In the lab 02. I can mention that briefly. Yeah. Uniform access principle. How do you understand it so far? How do you understand it from the tutorial? Okay, that's fine. Let's say this. Let's use an example similar to your tutorial example. Okay, let's say we got a class called bank, like a clients. Okay. Okay, let's say we got bank over here, effective, and then what we will get, let's say transactions. Okay, it's going to be, you know what? Let me make it more interesting for you. Let's say I got another class over here called transaction. Okay, effective, value, integer, just make it, simple. And then let's say I have a client supplier label over here, okay? And then I can say TS transactions, okay? I can spell it out. Okay, I can say array, okay, dot dot, right? That's something you should know already. Okay. Say this. Okay, so now let's say I got another feature called balance. Integer. Oh, if you don't mind, I want to change this rather than bank. I want to say clients. I think that'll be better. Okay, balance. How many ways there? Okay, what does that balance mean? Balance simply means I want to add up all the values of the transaction for this particular clients. So for the value there, it could be positive if you're talking about transaction for deposit. And the value could be negative if you talk about the value for, if you talk about transaction for withdrawal. Okay, either positive or negative, right? Now, for the balance over there, from the external user's point of view, right? Let's say I got another another client over here. Let's say I have a class called app. And the app is basically using, okay, this particular clients. I would say clients, C. Okay? From the application's point of view, right? All they know about the balance is it's going to be an aggregate value for all the deposit and withdraw for all the transaction. Okay, good. So now, a question for you. In the applications code, okay, in the applications code, if I declare, for example, C of type clients, that's why I got this client supply label. When I say C is assigned to, for example, 200 to begin with. Oh, sorry, let me say it again. Wrong. If I say C dot balance is assigned to 200, just to say I want to arbitrarily give this particular client 200. Now, in Java, we know that this will be allowed, right? Because the fact that we declare balance like this way, we know the balance is attributes. So I can say C dot balance is assigned to 200. In IFO, if you do this one here, maybe many of you have experienced that. This will not even compile. Why is that? That's true, but go a little bit deeper. Yeah, Chelsea. Actually, from the external user's point of view for client, we don't know how balance is implemented. Balance could be an attributes. Balance could be a query. We simply don't know. Okay, that's actually a very important design issue over here, right? In Java, the way they distinguish between method and attribute is by saying, if you see balance over here, just like that, integer balance, you know that it's an attribute. On the other hand, if you say integer balance like that with parentheses, you know that's a method, right? Somehow, the clients, when using the balance like this or balance like that, they have to distinguish between them, so it's not uniform. In IFO, what they support is, when I declare something like this, okay, you don't have to commit as a supplier. It's an implementer for clients. Whether the balance should be an attribute or should be a query. It's like an information hiding, okay? So now, let me go a little bit deeper, okay? For this particular balance over here, how can that be implemented? It can be implemented either as an attributes or it can be implemented as a query. If it is implemented as an attributes, you might just say, internally you can say balance is assigned to balance plus some amount if you talk about deposit, right? If you talk about withdraw, you just minus. Just internally, you can update the attributes when necessary, okay? If there's a query, all you got to do is you got to implement it. So you can simply say across the transactions, and then you just add up together, right? It's a query. Okay, let me finish this, okay? So now, when this external application over here, when they say C.balance is assigned to 200, right? They don't actually know how balance is actually implemented. It might be option number 1, in which case it's okay. You can assign to the attributes. But if there's option number 2, can you assign to a query? You cannot, right? So that's why this is not allowed in general, okay? That's more like a uniform access principle, which means from the external user's point of view, the way they access a particular feature is uniform, regardless whether the feature is implemented using attributes or a query. Okay? That's uniform access principle. Make sense? Yes? No, wait. I'll come to you. Yeah, I want to make sure I finish this discussion properly. I'll come to you. Yeah. Yes? It's going to fail, for sure. Whether it's being implemented as a query or as an attribute. Correct. Yes. Yeah, that's correct. Yes. Okay, any question about this particular uniform access principle? Okay. Okay. Yes, back to you. Sorry, which lecture are you talking about? Okay. Okay, what about it?
So on iPad, you got us started with some it said for all j,
Mm-hmm.
range said 1 less than equal to j,
Mm-hmm.
less than equal to I.
Mm-hmm.
I remember from find max it was j.
Oh, yeah, exactly. So that's why I said I was just sketching the solution, right? Depending on the particular implementation you might be given, you may have to say I, you may have to say I minus 1. That's my point.
So like because invariant is checked at the beginning of the loop,
Mm-hmm.
like it's checking the I guess you can it's checking the previous iteration and
Yeah, that's correct. So in the beginning, you have no previous iteration.
Yeah.
So in that case, well, again, it depends on how you set up the i's initial value to be. For example, if the particular implementation I give to you, if I simply set i's initial value to be, let's say 0, in that case, I will be okay, right? On the other hand, if I set I to be, let's say key star lower, in that case, it will be 1. So that would not be appropriate as we learned from the find max. So my point is, whether that should be I or I minus 1, it depends on the particular implementation I give to you. Okay? But maybe more straightforward to your question. For this particular case, I will be assigned to lower, which is 1. So you may want to say I minus 1, yes.
because when you at the end it increments by 1, right?
Correct, that's correct.
So if you do less than equal to I, then it will check even I.
You will actually check even I, which is yet to be done in the next iteration, yeah? Okay, and that's a very good. So that's a very important insight to get into, yes. That's good, yeah. So, yeah, so basically over here, should it be I or I minus 1? You got to decide, okay? Good. Okay, we got 10 minutes. Time flies. Yes, who? Yes. And the slide before that? Sure. This one? Okay, let me see this. Okay, let me see this. Consider. Okay, so basically this one here is a correct version of the loop invariant, right? So what's the question again? Sorry. Oh, why is not checking the loop invariant? The reason is, I will refer you to this diagram here. Okay, now I see what you're asking. Remember this particular diagram over here? Okay, this diagram here? Okay, if you see this diagram here, when we try to do initialization for your loop over here, and then the first thing you check before you even check the exit condition is the loop invariance. According to this diagram, what will be the first time you check the loop variance? It will be after the first iteration, right? Okay, if you don't mind, okay, let me make it more explicit for you. Okay, there's something actually we talk about briefly, okay, just about what will be the timing of checking things. Okay, that's a diagram over here. Okay, according to this diagram, let me make it a little bit bigger. Okay, like this. Okay, so now you can see that after the initialization for the loop, okay, the first thing you check is the loop invariance. Okay, so now you can see that loop invariance is checked. First time before the first iteration. Okay, that's something to note. And then, let's say if there's really a first iteration, because the exit condition is actually not true for the first time. And then you execute the body of the loop over here. At the end of it, you're going to check to see if the variant is actually larger than or equal to 0 or not. So that's the first time. Okay. So now you would say that the loop variance checked the first time after the first iteration. Okay, if I go back to the loop over there, sorry, the table that you were referring to. So now over here, so this is initialization, right? So after initializing it, we only check the looping variance, as I show in the diagram. But we don't check the loop variance. We only check it the first time after the end of the first iteration. That's why. Right? Okay, any more questions? Another little bit hints for you. Okay, so remember we actually talked about quite many exercises about postconditions and preconditions, like on the iPad. You may want to review them a little bit. Okay, now the various issue we talk about the postcondition, right? I don't quite remember if I can find some example for you, but I don't quite remember which one it is. I can try. Of course, if you got any trouble with them tonight, you can definitely refer to the lecture recording if necessary. Okay. Let me give you some example. I'm not too sure if I can find it easily. Okay. Give me one moment. Possibly. For example, right? So this is a kind of exercise we did in the class, right? I think we did quite many of them, throughout the course. You may want to review some of them or every one of them just to make sure. Can you actually explain what the issue was when I posed the question? That will be the kind of question you will be asked in the exam. Yes? Uh-huh. Okay. Okay, I might see what you mean, but let me go to the slides. Sorry? Oh yeah, that's okay. Yeah, don't worry. I'll go to the slides. Yeah, yeah. I briefly talked about it yesterday, but there was no sound recorded, so yeah. Okay. Yeah, you're right. Yeah, there we go. Thank you. No, not exactly the last, but yeah, there we go. Okay. Okay, basically talk about this slide here. Okay. Okay, let's talk about it again. So these are all the potential postcondition for this particular feature, right? Every one of them compiles, but only one of them is suitable. Okay. So we talked about it briefly yesterday, but of course you can also refer to the lecture recording back earlier. Let's say for this guy over here. How about we talk about these two guys? Okay, the first two. Again, let me just copy these two. Okay. Would you mind if I run a little bit over time? Would that be okay? Not too much overtime, but a little bit. Okay. Okay. Okay, so this guy here, let's say the first one. The first one here, why would it not be appropriate? That's an important question. That's true. So let me ask you this. Is this postcondition here always going to evaluate to true or always going to evaluate to false or something else? Always true, right? Okay. It's simply because when you say old accounts over here, so that means, let's say accounts is over here, which is some array over here, right? The first one here is simply just going to make an alias over here. So that means when you compare these two references, it's trivially true. Similarly, for the second one that Chelsea you were asking, right? If I say old accounts that twin, what's that twin? What that would do is it's simply just going to create a new array, whereas the second level will just be sharing all the account objects, right? So now this will be the second one. So now if you compare this, now when you compare this reference over here and this reference over here, it's trivially false, right? Okay. Yes. Oh yeah, of course. Okay, let me make it clear. You're saying I eventually reassign some account objects, right?
No, we make accounts be array pointing to another array.
Oh, in that case, of course, it will be false. That's true. Yeah. So that's a different kind of change. I'm just trying to say if you're trying to change the array itself. Yeah. Good. Yeah. Of course. Okay. You got about 1 or 2 minutes if you wish. Any more questions?
Can you just go over the rest? No questions.
Huh?
Probably, can you just like go over like?
You got a question? Okay, you can go first.
Oh yeah, that's
When the no. I would say it's more okay. You can think about deep twin is the kind of the strongest postcondition you can write, okay? But it may not be necessary. So writing deep twin always is okay, but it may not be so necessary because that may be kind of less efficient than necessary, okay? But when you say twin, okay, let's say this. Accounts is over here, which is pointing to some accounts objects, okay? Some objects over here. And now let's consider, it's really about what you really want to assert, to what level, right? If you say out, oh, actually, let me say it this way. Let me put it slightly differently, okay? I think that'll be even better. Okay. Accounts, the same as old account. That's one of them, okay? Versus deep twin. Okay, let's say this. I would say if you can afford the runtime inefficiency, you can always write 2. But conceptually, sometimes it might be the case that you can just write 1, and that would be able to capture all the error that might occur. Okay? So now, for number 2, let's say for number 1, what kind of error can they catch? If, let's say, for example, if the implementation is simply, think about what this one will do. All accounts. It's simply just going to say all accounts. It's just pointing to another array over here, whereas it's going to share. That's twin. Yes, I'm just talking about twin. Oh, sorry, I really meant to do twin. Sorry about that. Yeah, because you were asking about twin. Okay, so the twin over here is really sharing the objects. Okay? So now, when can this be useful? Let's say the malicious change I'm trying to make is simply say, let's say when I execute whatever feature I'm having, I simply say now, rather than pointing to this, is now going to point to another junk objects. This, if you know that this is the only kind of change that might happen, you can just use twin. Now, if you know that it's possible, maybe the kind of change might be I simply going to modify something in this particular object. In that case, twin, because they're sharing the same object, so they cannot tell. In that case, you must use deep twin. Okay, so here's the lesson. Always use deep twin. However, in the question, I might just ask you, is it really necessary to use deep twin in this case? You got to judge, right? So again, you want to review maybe those examples again. Yeah. Okay. Yeah. Is it short or?
Very short.
Go ahead.
So,
yeah, guys, bear with me 2 more minutes.
So go
Yeah.
back to last one.
Okay. Last one?
No, last iPad notes, like the previous one. Previous iPad notes. Yes, so if I get accounts like tell the old accounts stuff with that like it's I expect it's evaluating true, well like this correct?
Tell the old accounts dot twin. Basically, what this will do is tilde is going to be calling the is equal on the array, assuming the account is array. What that will do is it's going to compare the objects. Oh, okay. Okay, let me say this. Let's say you talk about twin, right? Let's say this is twin array. So that means they're going to share objects, first of all. Okay, let me just draw a few. Okay, they're sharing the accounts object, right? So now, when you say accounts, tilde, all accounts are twin. Basically, if the kind of changes you're making is just about reassigning the account to something else, that can be caught. But if you're making something specific beyond the second level, in that case, you cannot really catch that. So in that case, you got to use deep twin. So that is why this is also not appropriate. Because changes made on accounts, objects, cannot be identified. Yeah, you may want to review that part a little bit more. Okay, guys, any more last minute questions? Yeah. I will. So basically, I'm just going to get into any one of you who have some issues about your grading. I'm going to look into them, and then I'll get back to you. Hopefully, maybe not tomorrow, but over the weekend. Okay. And then the plan will be we'll try to grade your exam on Monday and Tuesday. Once we got the results, and then we're going to calculate your marks very soon. Okay. And then we might, well, depending on the timing, we might just maybe host an office hour to let you talk to me if you wish. Okay. But that part is not guaranteed. Okay. But I'll try. Okay. Okay. Any more questions for me? Yeah. No, nothing to do with short circuit. You just want to talk about reference copy versus shallow copy and deep copy. Yeah. Okay, good luck. See you tomorrow. Okay.